so let's have a look at this first example. Now, remember, when we are simplifying, what's really important is that we're looking for like terms in an expression. And a like term is a term that has the same variable and exponent. So if we look at question 1 here, we've got x plus 3x minus 5. So what I always do, and you don't have to do this, you must do what works for you. I always have highlighters or colored pens with me, and I start to highlight my like terms. So what I see here is x and the plus 3x are like terms because they both have an x and those x's both have the same exponent. Remember, just quickly, if there is no exponent there, there's actually an exponent of 1. We just don't have to write it in. And so because those exponents are the same, they are like terms, which means I can add them or subtract them, whatever the operation is telling me to do. This minus 5, let's see who remembers from last week. What do we call a term that is just a number? And pop it in the chat for me. Awesome, Jada, well done. A constant. So if it is just a term with no variable, it's called a constant. And well done, everyone. I'm seeing them all coming through. Awesome. And so that is now a separate term or separate group of terms. So now I can go and add. When I add x plus 3x, I get 4 x's in total. And then I have my minus 5. Because there's nothing that I'm adding or subtracting to the minus 5, it stays exactly as it is. Okay, so I'd like you to give number 2 a try. I'll give you a few minutes to have a try by yourself, and then we will have a look at the answer. So try number 2. You can put your answer in the chat so we can all see what's happening. Number 2 is negative 2x cubed minus x cubed minus x minus 2. So start by looking for your like terms. And remember, if you have a question, just pop it in the chat or raise your hand.
I see you, Tandy, being focused over there. Well done, girl. Remember, if you are feeling stuck, you can raise your hand. Matidi, so I also see you.
Right, so if you are feeling a bit stuck, like I said, the first thing you want to do is, all right, so we're looking at question 2, just that we all know where we are, and we're trying to simplify this expression. So we want to look for the like term. So like I say, if you're feeling a bit stuck, look for your like terms. Remember, same variable, same exponent. So here, the minus 2x cubed and the minus, whoops, and the minus 3x cubed. No, I'm going to start that again. The minus 2x cubed minus 3x cubed are like terms because they both have x's with a cube, so with an exponent of 3. This minus x is then a separate term by itself because even though it's an x, it doesn't have an exponent of 3. And then I've got my constant. So I've actually got 3 different groups of like terms. So I'm seeing some answers coming through, so I'll give you a second if anyone else wants to pop an answer in.
So we have Matsirisa on the line. I'm just going to let him unmute. Matsirisa, if you can press the button that is asking you to unmute.
Evening.
Hi.
Oh, hi. Sorry.
Can you please repeat number 1, please?
Would you like me to go over how we got that answer again?
Yes, please.
Okay, cool. So when we want to simplify an expression, we want to look for like terms. So like terms are terms that have the same variable and the same exponent. So in this first question, like variables, like terms, my brain. So in this expression, the x and the 3x are like terms because they both have just x's. And then the minus 5 is a separate term. So what it means is I can add x and 3x together to make it simpler to just have 4x. And so when I add them together, I've got 4x. And because I can't add or subtract anything to the negative 5, it just stays -5. Does that make a bit more sense?
Okay, thank you.
Perfect, cool.
Thank you, Matsidisa, for asking.
Okay, cool. Let's have a look at this question 2. So question 2, I'm just going to zoom in here a bit. I've highlighted the like terms for us. So we can now add those like terms. Minus 2x cubed minus another x cubed. Remember, if you need to, draw a little number line for yourself or use your calculator. It's really up to you. If we are already starting at -2x cubed, and I'm going to take another x cubed away, I'm moving more towards a negative value. And so what that means is minus 2x cubed minus another x cubed is minus 3x cubed. Now, because the minus x doesn't have any terms I can add or subtract to it, we just leave it as minus x, and the same goes for the minus 2. So my final answer here, once I've simplified, is negative 3x cubed minus x minus 2. So I see some of you had a different coefficient for the x cubed, so just make sure that you are subtracting or adding your terms correctly. Cool. Right, have a try of question 3 over here. So if you're feeling a bit stuck, just work slowly. Remember, we're looking for like terms, so they have to have the same variable and the same exponent. So in this expression, we've got minus 2x squared y plus 3xy squared minus 3xy minus 5x squared y plus 2xy squared. So I'm going to help you a little bit just with the like terms because there's quite a bit going on here. If I look at my first term, I have an x squared y. So I want to look for any other term that has the same combination, x squared y. The only other one that has an x squared y is the minus 5x squared y. So those are like terms. And then I keep going. The next term is positive 3xy squared. So I want to look for any terms that also have xy squared. And that's the positive 2xy squared. And then the little negative 3xy, it doesn't have any like terms with it. So that's a separate group by itself. So I'll give you a minute or two to try and simplify and give me a final simplified answer for question 3. And remember, put it in your chat, or if you have a question, put it in the chat for me or raise your hand and we can sort it out.
Well done, my people. You guys are doing really, really great. So remember, I see Tandy's writing on her book, which is great. So everyone is writing, right? So we can do corrections afterwards. Okay.
Okay. I'm not getting many answers here, so we're going to have a little look. If we now start to add these like terms that I've highlighted, I'm just going to start with the x squared y terms. So again, if you need a number line, that's absolutely fine. It's not a very straight line, but anywho. If we have a minus 2xy, we're already starting with a negative. So we need to be mindful of the fact that if I'm going to take more away from it, I'm going to get an even more negative number. So I've got a negative 2xy, and now I'm subtracting 5xy's, x squared y's, 1, 2, 3, 4, 5. So I'm taking away even more, so I'm getting more and more negative. So the x squared y term simplified to minus 7x squared y. Then I've got my xy squared terms. Now this is a little bit easier. 3xy squared plus 2xy squared is plus 5xy squared. And then because I can't add anything to the minus 3xy because it doesn't have any like terms, I just put it in my expression as it is. And that is my simplified answer. Okay, now just quickly, just because I can see in some of the answers, if the order of your terms in your answer is different. So for example, just going to write it in another color so you can see what I mean. If, for example, you put the plus 5xy squared first, and then the minus 7x squared y, and then the minus 3xy, that's absolutely fine. That's exactly the same thing. As long as your term has the correct coefficient with the correct sign, that is absolutely fine. So if your terms are just in a different order, don't stress about it at all. Alrighty. Another thing to just remember is that when we add and subtract like terms, the exponent doesn't change. All right. So for example, if I just use the terms I've highlighted in yellow, for example, so the minus 2x squared y and the minus 5x squared y, when I add or subtract those two, the x squareds, I don't then subtract the exponents, or I don't add the exponents. Those exponents stay exactly as they are because I'm adding or subtracting. The only time an exponent changes is when I multiply or divide. Right, so that's just something to bear in mind. I'm seeing all these correct answers coming through, which is absolutely wonderful. Well done, grade 8. All right, so I'm just going to take a second. Does anyone have any questions about these 3 examples before we move on? Thumbs up if you're okay in the chat.
So we want to see, so if you can please vote. There we go. Now I see the thumbs up. Let's go. Remember, you are saying that you understand the work when you're showing us thumbs up, which is great. So you can show us whether you understand or what's going on. If you don't understand, then it's thumbs down and you can ask questions because Teacher Sam is just so good. Well done, guys. Well done. I see those thumbs up. Woo! We are understanding, Teacher Sam. We are all yours.
Great. Okay, that's excellent. Right, so let's have a look at something slightly more complicated examples. So when we start to simplify more complex expressions, there's 3 easy steps that we need to remember. And honestly, guys, if you can do these 3 things, simplification of expressions becomes so much easier. All right. So the first thing that we want to do is sort of what we started doing in the first lesson, which is identifying your terms. So basically, how many terms are you working with? Right. And I'm going to do these 3 things as we work through some of these examples. And you don't necessarily have to write down step 1 and then do it. It's just something to bear in mind. So that's the first thing. I want to identify each of my terms. The second thing I want to do is I want to simplify each term. So I want to simplify the individual terms. I'm going to just underline that because that's super important. If we start mixing up our terms, we're going to simplify incorrectly. And then finally, the third thing is once you simplified each term, you can now simplify the whole expression. Okay, so if we can do these 3 things, spelling. If we can do these 3 things, then we can simplify algebraic expressions. Alrighty, so I'm going to do the first 2 with you, and then we'll have a look and see and get you to try some by yourself. So let's look at example 1. We've got 4 times x minus 2y. So if I look at the expression as a whole, and if you need a little reminder, terms are separated by plus and minus signs. There is only one term in this expression because basically what I have is 4 times a bracket. And times or multiplication sign doesn't separate terms, so I've actually just got 1 term. So this is my one and only term. So that's step 1 done. Step 2 is to simplify this term. Now, if I'm multiplying the 4 by the bracket, what we need to do is we need to multiply the 4 to each term inside my bracket. So I need to multiply the 4 with the x, and I need to multiply the 4 with the negative 2. Now, if you want to, this is not something you have to do, but if you just want to build your confidence a little bit, what you can do is you can just sort of on the side of your working out, do your multiplication separately. So we have to multiply 4 and x, and we know that that gives us 4x, and we need to multiply 4 and negative 2y. I'm just putting in a bracket because I've got a negative there, so I want to make sure I remember to multiply that negative. When we multiply a positive and a negative, I end up with a negative And so 4y times negative 2y is negative 8y. So I'm seeing some lovely answers in the chat. I can then put those two together into my answer, and I've got 4x minus 8y. So that's me simplifying my term. I can't do anything more than that because those are not like terms, so I can't subtract them. And so that's my final answer. Excellent, guys. I'm loving that I'm seeing this correct answer going on in the chat there. Well done. Okay.
Hey, I'm proud of all of you guys. Remember to mark. Okay, so if you did get it wrong, however, now you can understand it, like Nathaniel is saying. And if you don't understand, raise your hand. Teacher Sam is here with us. She's gonna help us.
Cool. Well done. If we have a look at example 2.
Before we look at that, I just have some questions. Do you mind taking some questions, some few questions? Is that fine?
Absolutely. If you are confident, try and see for me just an example 2 how many terms you have, and just be careful there. But let's hear the questions.
Hi, Tam.
Hi, ma'am. Wait, ma'am, can you hear me?
Yes.
Yes, we can.
Okay. So, if you don't mind, can you please explain number 1 for me again? I don't understand quite.
Okay, cool. So in number 1, what we have is 4 times a bracket. Now that 4 is essentially what we call a coefficient.
Okay.
Coefficient. And anytime I'm working with a coefficient, it means multiplication. Alrighty, so what I need to do is I need to take that 4 in front of the bracket and multiply it with both terms inside my bracket. So that's why I've got the little arrows there. And I'm just going to take them off and redraw them. I have to multiply the 4 with the x, which is what I did over here. And I need to multiply the 4 with the negative 2, which is what I did over here. That is then simplifying that expression. If I have brackets, it's telling me I need to multiply, and by multiplying, I've then simplified. So 4 times x is 4x, and 4 times negative 2y is negative 8y. And so that's where I got my final answer from, by multiplying away the bracket or multiplying out the bracket. Does that make sense?
Yes, ma'am, it makes sense now. Thank you.
Okay, good.
Thanks, Sam. Okay, so we have Nandi. Let me just ask her. Hi, Tandy.
Hi, Tandy.
How are you?
Good, and you?
Okay, so I'm a bit confused by the second one.
Okay, cool. So the second one I've put here because it often confuses us. So I'm kind of actually glad you're a bit confused about it, because that means we're on the right track. So let's have a look at question 2. So I had asked, identify your terms. Now, what often happens is we see 4 minus 2 and we see, okay, cool, I know what 4 minus 2 is. It's 2, and we go with that. But I need to be careful of the fact that these are actually separate terms. 4 is a term by itself, and then the minus 2 times the whole bracket is a separate term. And so we actually must not subtract 2 from 4 before I start simplifying, or when I start to simplify. They are separate terms. They must stay separate until I have simplified the second term. So basically until I have multiplied the negative 2 into the bracket. And this is where a lot of mistakes happen when we've got simplification. We think, okay, cool, let me just quickly subtract that. That's nice and easy. And then I can multiply it. They are separate terms. They must stay separate. Okay, so Tandy, is this starting to hopefully make a bit more sense about what the next step is going to be?
Yes, it is. Sort of.
Okay, cool. Well, let's do the next step. Alrighty, so because I can't simplify 4 is 4, I'm just going to leave it there. I can, however, simplify the second term. So I'm just going to label my terms A1 and 2. I can multiply it in. So again, if you need to, draw a little line down the side for your working out. We have got a negative 2 times a negative 3x. Now, can someone in the chat tell me what happens when I multiply a negative with a negative? What do I end up with? What sign?
Yes,
Excellent.
people. Well done, guys.
Right, we end up with a positive. So when I multiply -2 and -3x, I end up with positive 6x. Then I need to multiply the -2 and the -6y, and we've just discussed the fact that a negative times a negative is a positive. And so I end up with positive 12y. Now I can write those down. I've got a plus 6x and a plus 12y. And that has essentially come from me simplifying the second term. So just so you can see how I've gotten that, by doing this multiplication, I have ended up with these two terms. And that is what simplification is. It's making sure that everything that must be multiplied is multiplied, everything that must be divided is divided, and then everything that can be added or subtracted is added or subtracted. Okay, so my next question is, from this step, 4 plus 6x plus 12y, do I have any like terms that I can add together? Just a yes or no in the chat.
Sandy, I'm glad you can see it now.
Good, I'm seeing lots of no's. Great. We don't have any like terms, so I can't do anything. So that is my final answer. If I don't have like terms, I can't simplify any further, so I stop there. Okay, well done, everyone.
I think we have one question. Can we take it?
Yes, absolutely.
Hi, Deborah. Please click on that button. There we go.
Hello.
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 How are you?
I didn't understand.
Okay, which part don't you understand? Do you want me to explain it again from the start?
Yes.
Okay, cool. So first thing, so remember, if I just quickly scroll back here, I said there's 3 things we need to do. Identify our terms, simplify each term separately, and then simplify the expression. So if I go back to question 2, the first step, and I'm just going to take off all of my scribbles over here. The first step is to identify my terms. Now remember, a plus or minus sign separates my terms. There's minus signs inside the bracket, but we don't worry about those. We worry about everything that's outside. So if I sort of say, okay, which is term 1, which is term 2, I've got one term over here, and then because of that minus sign, my second term is over here. So I've got 2 terms. So that's step 1. I know which terms I'm working with. Step 2 is to simplify each term. Now, if I look at term 1, I can't do anything to that. 4 is 4. It's not being multiplied, divided, added, or subtracted. So that's why it just stays 4. However, in term 2, remember what is happening here is I've got minus 2 times that whole bracket. So I need to go and say, all right, I need to multiply the -2 into the bracket. And that's what I've done on the side here. I've multiplied the -2 with the -3x, and I've multiplied the -2 with the -6y. Once I've done those multiplications, I can then put those answers into my expression. I then do step 3, which is, can I simplify the whole expression? So do I have any like terms? I don't have any like terms, so I stop at that point. Does that make sense?
Okay. Yes.
Okay, good.
Okay,
Right.
we have Tando.
Tando?
Hello, ma'am.
Hello.
Hi.
So, ma'am, will it be wrong if you start with 4 instead of 2?
Okay, so explain a little bit more. How would you start with 4?
So, for question 2, so instead of starting with -2,
Yeah.
will it be wrong if you start with 4?
Okay, how would you start with 4 though? What would you do with 4? Because 4 is a separate term.
Oh, it's separate.
Exactly.
Okay.
So I don't know if you sort of, if you in the chats have a look, I don't know if you mean, can we say 4 minus 2 and then do the multiplication? If that is what you mean, the answer is no, because like I've just said, they're separate terms. So we need to keep it separate. And as someone sort of put here because of BODMAS, essentially, yes, we need to do the multiplication first before we do any additional subtraction.
Yes, ma'am.
Awesome. Cool. Well done. Right. Do we have any more questions? Or shall we try the next one?
We are good to go so far.
Cool. Alrighty. So another scenario we can encounter is when we have a fraction. So one of the ways we can deal with fractions, and there's actually lots of different ways we can deal with these fractions, and you'll learn about more ways you can deal with fractions as we sort of work on in maths. But one of the ways we can do it is we know that if two terms or more terms are written over the same denominator. So what I mean by that is I've got one term as 5x, one term as -10, but they're both written over the same denominator. I can actually go and separate this fraction and then simplify each term. So I can write 5x over 5 minus 10 over 5. That means exactly the same thing. All I've done is separated my fraction. And what that allows me to do is separate each term individually. So going back to that, simplify each term of your expression. Right. Now we have to be careful when I start to divide. There's lots of different ways you can think about this. There's lots of different ways you can do it. You have to do what makes sense to you. So my method of simplification with fractions is I always cross cancel, but there's a reason I cancel. So if we look at this first term and just let you know which term is which, we now have two terms over here. Oopsie daisies. I now have two terms. If I look at just the first term, so the 5x over 5, we want to see how we can simplify this. Now, we deal with the numbers and the variables separately. So if we just look at those 5s, can anyone tell me in the chat what 5 divided by 5 is? Awesome, well done. And so when I say what I do is I cross cancel, is I say, okay, cool. Well, 5 divides with 5, leaving me with 1. If that's how you want to do it, go for it. It's completely up to you what you're more comfortable with. But at the end of the day, we simplify down to x. If you want to put 1x there, that's absolutely fine. You don't have to put the 1, but you'll never be marked wrong if you do. Okay, so we then move on to the second term. I've now got a -10 divided by 5. So if we just leave the negative for a second and we just deal with these numbers, again in the chat, what is 10 divided by 5?
Yeah.
Awesome, well done. So we've got 2. We know we've got a minus sign there, so we remember to put that in, and we've got our x or 1x minus 2. So when you have a fraction, remember you can separate your fraction and simplify each term. Awesome, I'm loving this, well done.
Please do mark yourself and correct where you went wrong, okay? It's always important. And ask us if you don't understand.
Please.
Teacher Sam is here to help us.
Alrighty, so let's take a brain break before we have a look at that one, just because there's something I want to chat about there. So get up, stretch, move your body. And then
let's do this, guys. We deserve it. We deserve this break.
And then you'll see, just as a bit of a use your brain slightly differently, I've got a magic square here. So if you have never done a magic square before, don't stress. I've put a little explanation there for you. Essentially what it is that if you move along any horizontal, vertical, or diagonal line and you add up the numbers, any line you move along, you get the same sum. So you get the same answer when you add them up. So I want to know what the values of A, B, and C are. So once you've done your stretch, touch your toes, do your jumping jacks, let's see if anyone can tell me what A, B, and C are. Ukanyo, do you want me to explain it again?
So guys, I'm just gonna, I can also read the instruction there for you. So it says, this is a magic square. The sum along any line horizontal, vertical, or diagonal is the same. Do you hear what is that? Do you know what that's supposed to mean? Can you find the missing numbers? So the sum along any line, meaning when we go horizontal, when we go vertical, even when we go diagonal, the sum has to give you the same numbers.
Okay, if you're still struggling, I'm going to give you a little clue. You've got a diagonal here where you've got all of the numbers. So I would start with adding up those three numbers and see what your answer is, because then whatever that answer is, it must be the same when you add a plus 7 plus 6, and it must be the same when you add 6 plus b plus 8, and so on. So that's what a magic square is.
So we have Setu. Setu says A is 2, B is 3, and C is 1. Setu, have you added your numbers? Let me just quickly try and see if Setu is right.
Yeah, so
So said to, if you see there, when you put your C as 1, I don't get the 15 that you're supposed to be getting. So do you want to have a look again at your numbers, Setsu? As you will have
a bit of a clue in there. All right, and guys, don't stress if you don't like get these immediately. This is just a little challenge. I'll explain it and then hopefully it'll make more sense, but just give it a try. That's what maths is all about, okay? I'll give you a little help if you need. So remember I said, if you add any numbers up, you should get the same number. And I said, start with this diagonal. So if we add 6 plus 5 plus 4, you should get 15, which means if you add any horizontal, any vertical, any diagonal, you should always get 15. Okay.
I think I have a winner though. Oratile did it. Well done. I checked your answers, Oratile. So Oratile, can I say the answers that Oratile said, Teacher Sam?
Absolutely.
So Oratile says A is 2. So if we add the horizontal, we can get 15 with that. And he said B is 1. So if we add the vertical, we're going to get 15. And he said C is 3. And if we add the horizontal, we will get 15. Well
Awesome.
done.
Well done. So just as a quick thing, if you didn't follow what was happening, I'm just going to do A so that you can see how all the rest would be done. We know that it has to add up to 15 any line that you use. Now, if I say 7 plus 6, I already have 13 along this line. So what I'm missing is another 2. And so that's why A is equal to 2. And so we use the same logic to get B and C. So well done if you got A equals 2, B equals 1, and C equals 3. Well done, guys.
Well done, guys. You nailed it. Sandy, wake up. Wake up, girl. Wake up. I see you. I see
you. Got this.
you.
Alrighty. So the next one that I want to chat about is question 4. Now, the reason this can sometimes get a bit complicated is because what you actually have going on here is you only actually have one term that you're working with. So this is one term. That's it. Now, if I break this down a little bit, what this is saying is 2x times the bracket x minus 3 times y. Now, we need to remember that the order in which I multiply values doesn't matter. If you say 2 times 3, you get exactly the same answer as 3 times 2. So the order in which you multiply things doesn't matter. Now, the easiest way I find to deal with something like this is when you have 2 things you need to multiply into the bracket. So here I need to multiply the bracket by 2x and 2y. What I do is I actually multiply those ones first. Those are essentially, oh golly, those are the coefficients to your bracket, and I would multiply them first because it makes your life a little bit easier. So if I say 2x times y, what I end up with is 2xy, and that I still need to multiply with my bracket x minus 3. And we know how to do that. We've done quite a few of them now. All I now need to do is multiply the 2xy to the x and the 2xy to the negative 3. Alrighty, now we need to be careful because when I do this multiplication, I'm multiplying an x with an x. And if you don't know what I mean, I'm saying 2xy times x, and the other multiplication I need to do is 2xy times negative 3, which we'll do now in a second. And this goes back to what I said earlier. Anytime you multiply variables, we change the exponents. So let's just put a little, when we times variables, the exponent changes. Just need to do that, changes. Oh, golly. Alrighty, so 2xy times x. If I just break it down to multiplying the x's together, can someone pop in the chat for me what x times x is?
Angela, is that hand to answer the questions? Because guys, you can also answer the question by raising your hand. I'm sure Teacher Sam will love it. Hi, Angela. You can.
Hi, ma'am.
Hi. Do you have a question?
I wanted to ask you why the y went to the x. Yes, ma'am.
Okay.
Yeah.
Okay, so
Ma'am.
so why the y went to the 2x?
Yes, ma'am.
Alrighty, cool. So the reason for that is both the 2x and the y. So both of these things are coefficients. They are things that we want to multiply into the bracket. Now, to make my life easier, rather than saying, okay, what is 2x times x and then 2x times minus 3 and getting those answers and then multiplying the y into the bracket again. So instead of doing all of those multiplications, what I'm going to do is I'm actually just going to say, okay, cool. Why don't I multiply the 2x and the y together to get 2xy? And then I can just do one multiplication into my bracket. It's not to say any other way is wrong, but this simplifies the whole multiplication process for you.
Okay, thank you, ma'am.
Okay,
And
cool.
probably the easiest.
I think it's the easiest. If you are dead set against it, you definitely can do it the way I've just said. So you can multiply the 2x in and then the minus 3, the 2x to the x and the 2x times the minus 3, and then you can multiply the y to those two answers. That's fine. There's nothing wrong with that, but it is a little bit more complicated.
Hi,
Okay.
Matsiriso. So Matsiriso's online.
Hi.
Hi.
Can you please explain for me number 4? I didn't understand.
Okay, so we're still busy doing number 4. What I've just said is we can multiply the 2x and the y together to make the multiplication a little bit easier. So if you've got two things, one in front of your bracket and one or at the end of your bracket that are both being multiplied, what we can do is we can multiply those two things together and then multiply into my bracket. But we're still busy finishing question 4.
Okay.
Okay. All right, guys, so I asked the question, what is x times x? Just a basic multiplication of variables. Now I want you to be careful here, and I'm going to put a little square. Whenever I multiply the same variables, remember what happens is we add exponents. So this is going back to your exponent rules. Each of these x's have an exponent of 1, and so x times x is actually x squared. So I saw a lot of 2x's in the chat. 2x comes from saying x plus x. So if I'm adding 2 x's, I get 2x, but x times x is x squared, right? So you need to go back to your exponent laws if you're not 100% sure on that. But anytime I multiply, my exponents change. Alrighty, so what that leads me into is being able to multiply 2xy with x. So 2xy times x is then 2x squared y. And then my second multiplication of 2xy times negative 3, we've spoken about the fact that a positive times a negative is a negative. 2 times 3 is 6, and then I have my xy. So once I've gone and multiplied my 2xy into the bracket, what I have as my answer is 2x squared y minus 6xy. Now, can anyone tell me if those two terms are like terms? Just a yes or a no in the chat. So are they like terms?
I can see Tandy shaking her head, meaning no. We got that one, Tandy. Thank you.
Excellent, guys. I'm seeing lots of no's. That's great. They are not like terms because the one term has an x squared y and the other term just says xy. Because the x's don't have the same exponent, they're not like terms, so I can't add them together. So I stop. I'm done. I've simplified. Okay. I know that was a lot of information to get. So take 30 seconds, deep breath before we move on to the next examples.
Yeah, you can also take screenshots. Hey guys, if you are writing all the notes and you feel like you're not done yet, take a screenshot with your phone or with whatever device you're using. You're welcome to take a screenshot so we can move on. Joshua, shout out to you. I cannot see you. I hope that you're working.
All right, lovely people. Let's have a C. Okay. Example 3. I'm going to start this off, but then I'm going to ask you to finish it off. 3 steps that we need to follow: identify your terms, simplify each term, and then simplify the expression. So I'm going to start you off by identifying the terms. Over here in this expression, what color should we use? Let's use green. In this expression, I have 2 terms. Remember, this plus is separating my terms. I don't care about plus or minus signs in the bracket. I care about the ones outside the bracket. So I've got term 1 and I've got term 2. So you are now going to do step 2 and 3, where you're going to simplify each term and then simplify the whole expression. Right, so have a try. If you've got some answers, you can start putting them in the chat by all means. I'm excited to see. Oh. And guys, like I said to you, if colors work for you in your maths, use the colors, use the highlighters, draw the arrows to show your multiplication into the bracket, do all of these things and anything that you need to do to help you get these questions. Okay, cool. So quickly again, I've got my 2 terms there, 3y and then the 7 times 2y plus 6. I want you to try and simplify that. So a little hint is I can't simplify term 1 because it's just 3y, but I can simplify the second term by multiplying the 7 into the bracket. So that's sort of the start of what you need to start doing. So try multiplying into the bracket first and then see what you end up with, and then we'll go from there.
I can already see some different answers. Let's see which one is right. And if you do feel confident, you're allowed to tell us your answer and how did you get your answer. I think Teacher Sam will be very interested in knowing how you got your answer. Okay.
Yeah, I'd actually like that. If anyone wants to raise their hand and explain how they got their answer, I'd love to hear. So if you're feeling brave, I'd love to hear your.
And plus you'll be learning.
Yeah.
Remember, we are here to help you. Woo! Thank you, Setu. Thank you, Setu. Let's hear.
Ma'am, I got 17y plus 42.
How did you
Excellent.
get it, Setsu?
Yeah.
I first started by multiplying my 7 with my 2y, and I
Okay.
got 14y. Then I proceeded to multiply my 7 with 6, and I got 42. Then I added 3y and 14y, which gave me 17y plus 42.
Excellent.
Well done. Nailed it.
Okay, so I've hopefully written all of that down. That was awesome and well done. That was a very clear explanation. So we need to multiply the 7 into the bracket. And so 7 times 2y is exactly 14y. And I've just done it, whoopsie daisies, on the side here so you can see that multiplication. You don't have to show that working out. If you're happy to do just what I've written there, that's absolutely fine. So 7 times 2y is 14y. 7 times 6 is 42. And so we've got, let me take this weird circle off here. And so we've got 3y plus 14y plus 42. We can see that I actually now have like terms that I can add together because 3y and 14y are like terms. The 42 is just a constant. And so when I add 3y plus 14y, I get the 17y plus 42. So excellent, well done. Okay.
My people, you are doing great.
You are. Alrighty, so we're going to chat a little bit, but I'll get you to try this as well. Remember, first step, identify your terms. Now, don't panic when you start to see lots of terms and lots of exponents. Like I say, if you can do these 3 steps, promise you this whole process will become a lot easier. So term 1 is 3x squared. Term 2 is minus x times 5x minus 2y. Term 3 is minus xy. And term 4 is the 2x cubed over x. So I can't do anything with 3x squared. It's going to stay there. I can, however, in term 2, multiply the negative x into the bracket. So again, if you want to do a working out on the side, that's fine. I've got a minus x times 5x, which we now know when I multiply variables, my exponent changes. So I've got a minus 5x squared. And then when I multiply the minus x with the minus 2y, I get a positive 2xy, because as you've told me, a negative times a negative is a positive. Okay, so I'm simplifying each individual term. Term 3 can't do anything, it's just minus xy. But term 4, I can simplify. So this goes back to your exponent laws. And like I say, if you need to go back and have a look at those notes, I think the videos are all on the website. Please do that. But what we have here is 2x cubed divided by x. Now, there's lots of different ways to think about this. I'm going to do sort of a longer explanation because I think it makes the most sense. But you do it how you want to do it. The exponent law tells us that we subtract exponents when we divide. So if that's how you want to do it, that's cool. What I have is 2 times x cubed. Now, x cubed is x times x times x, all divided by x. Now, we know that when we divide something by itself, so if I had, say, for example, 2 divided by 2, I get 1. What that allows me to do is cancel anything that is the same in my numerator with the denominator. And so I can cancel an x there to leave me with just 2x squared. If you're going to use the exponent law, and I'm just going to do it below here, if you use the exponent law, we subtract the exponent. So 3 minus the exponent of 1, which is x squared. And so you end up with the same minus 2x squared in any case. Lots of different ways to think about it. You must do what makes sense for you. But we have now simplified each of our terms. So I'm going to give you a minute to see if you can now simplify the rest of this expression. And if you can, put your answer in the chat so we can all see. Tandy?
Quick question.
Mm.
The
the x, you multiply what's in the brackets, right? And
Yes.
this over the brackets, like by the other side. And you told us to multiply that with the x. So does it become 2xy or just x and y?
Okay, so I think I'm following you. So this is that multiplication that you're talking about. So it's minus x times minus 2y. X and y just stay x and y, and the negative times the negative gives me a positive 2xy. So it becomes 2xy. Does that answer the question?
Yes, thank
Okay.
you.
Okay, good, well done. Anyone got any answers for me? You can raise a hand, you can put it in the chat. I know this is quite a hard one, so by all means, take your time. I'll help you out a bit by, oh no, sorry, by highlighting like terms for you, and then hopefully that'll help the situation a bit.
So Teacher Sam, are we going to continue this next week, or you have another topic for us next week?
We do have another topic, but we can definitely do more of this.
I'm seeing the time.
Yes.
So
we are definitely going to carry on with this stuff. And what I'm going to do is I'm going to put the answer here for you guys to mark. And if you haven't finished it, write down the answer, and you can then finish the question and double check your answer. But we are going to carry on with this, guys. So if you aren't getting this 100%, don't worry, we will carry on, right? That is your answer there. You can double check.